Okay, we can go for example of Bernoulli equation. We go for example number 1. Okay, here for this example, okay, it stated that okay, the airplane flies at 100 miles per hour at elevated of 10,000 feet. So at the standard atmospheric shown in figure below. So determine the pressure at point 1, okay, far ahead of airplane, okay, which is pressure here. Then the pressure at stagnation point on the nose of the plane, which is point 2. So point 2 pressure, and the pressure difference indicate the pitot static prop attached the fridge. So pressure difference of pitot prop, okay, here. Okay, so there is a 3 things here. First is determine the pressure 1, P2, and also pitot difference of P1 and P2. Okay, and P2 P1 minus P2. Okay, so in this case, okay, when we get this type of questions, the first step is, okay, the first step is write your Bernoulli equation. So here is P1 divided by rho plus V12 divided by 2 plus GZ1 is equal to P2 divided by rho plus V2 squared divided by 2 plus GZ2. So that's your first step. The second step you need to do is find the info. What is your info? What is your information or info? Okay, now we know that P1 there is a that we need to find, which is pressure number 1. Okay, at point 1, so V1 also there is a velocity which is 100 miles per hour. Okay, then the third one is Z. Okay, Z is the potential energy. If you can notice here, there is the point of P1 and P2, it the same. There is no elevated of changes. So automatically P1 we have P1, V2 also have a number. So Z1 is equal to 0. So means that is a stagnation. So in P2, okay, so in P2 we have the pressure value V2 is equal to 0. Why? Because of the point of stagnation point. What it means of stagnation point means, for example, this is the airplane, the flow passing through it. At this point 2, there is the velocity will be 0 because of the flow is stagnation. So stagnant, V2 automatically 0. So then the third one is Z2 also is 0 because there is no potential energy effects. So here we can write it. We have P1, we have V1, but Z1 equal to 0. Okay, or we have P2, okay, we have V2 equal to 0, and we have Z2 equal to 0. So when we come back to the Bernoulli equation, Z1 is equal to 0. On your right side is V2 equal to 0 and Z2 equal to 0. So the third one is the final equation. So should be P1 divided by rho plus V1 squared divided by 2 is equal to P2 divided by rho plus, no plus means this is only the remain equation. So this one also, if we take P2 as the left hand side, we will get P2 is equal to P1, okay, plus rho V1 squared divided by 2. Okay, so we come back to the question. The first question is find P2. The question for find P, determine the pressure at point 1. So the pressure at point 1 and okay, pressure at point 1 okay is equal to pressure of static pressure at altitude of 10,000. So based on here, it should be 1456 lb per feet second. So it's an absolute pressure, or you can calculate it become 10.11 psia. Okay, done. So question number 2 is find P2. So P2, we need to use this equation, which is P1 plus rho V1 squared divided by 2. So here we will get our P1 is 14656 okay lb per feet square, okay, plus our rho is 0.001756 slug per feet cube, okay, square, sorry, there is no square, the V is square. Okay, so this one should be times with times with V. What is your V? V is 100 mile per hour. If we convert to feet per second, it become 146.7. So you need to times with 146.7 feet per second. Okay, then should be divided into 2. So here you will get your P2 is equal to P1 is 1456 plus calculation of this right, the sec P2 is 18.9. So this is P1. P2 is summation of these two things. This is in terms of absolute. So the third one is find the difference at P thought, which is P2 minus P1. So based on here, this equation, if P2 minus P1, we will get rho V squared 1 over 2. Rho V squared 1 over 2 is similar with this one, so you will get 18.9 lb per feet square, or 0.1313 psi. Okay. Okay, we go for example number 2. In example number 2, so it stated that there is a kids, okay, water is flowing from a hose attached to a water main of 400 kPa gauge. So a child places his thumb to cover most of the hose outlet, causing a thin jet of high speed. So it become high speed thin water at this area. Okay, so if the hose is held upward, what is the maximum height of the jet could achieve? So the question wants you to find the maximum jet, the maximum height. So means to Z2. Okay, as been mentioned previously, first is Bernoulli equation. Okay, first is a Bernoulli equation. So we need to write down a Bernoulli equation. So P1 divided by rho plus V1 squared divided by 2 plus GZ1 equal to P2 divided by rho plus V1 squared divided by 2 plus GZ2. The second step is information. Okay, here we know that okay, we go one by one. At point 1, okay, at point 1 there is a pressure effects. Okay, at V1, okay, velocity 1 is equal to 0 due to the starting velocity from point 1, and Z1 equal to 0 due to the datum. Okay, for P2 there is a value V2 also equal to 0, because at this point there is the maximum height when the flows the water start to be going down. So means here V equal to 0. So V2 equals 0, and okay, Z also we want to find. So from this info we know that okay, P1 there is a value, P2 V1 is equal to 0 and Z1 is equal to 0. For point number 2, P2 there is a value, V2 is equal to 0 and Z2 what we want to find. So from here the third step is you can cancel it. So we know that V1 is 0, so this one can be cancelled. Z1 is 0, this one can be cancelled. Then for P2 is Z2 is 0, this one can be cancelled. So the next is the final Bernoulli equation, which is the remaining one is P1 divided by rho is equal to P2 divided by rho plus GZ2. Okay, so another okay, so the question asks to find Z2. So if we simplify one Z2, you will get P1 minus P2 divided by rho G. Okay, this is final. The fourth one is complete it or answer it. Okay, so we know that the question give you P1 minus P2 is 400 kPa, which is the flow mean at 400 kPa. So the flow here, the difference is 400 kPa. Okay, which is P1 is 400 kPa, P2 is PATM. So PATM is zero. So we will get Z2 is equal to 400 kPa divided by rho. Your rho is 1000 kg per meter cube. Your G is 9.81 meter per second cube. So this one, so it should be times 1000 because of kPa. Okay, so at the end you will get the answer of 40.8 meter. So 40.8 meter is the elevated of this distance. So Z2 is 40.8